NASA just confirmed what shouldn't be possible. 2 days ago on November 5th, new images of 3I Atlas were released by observatories around the world. And something is missing. Something big. Something that, according to the laws of physics, should be impossible to miss. The debris cloud isn't there. Let me explain why this matters. Why NASA is now confirming Harvard's analysis, and why the next 42 days could answer the biggest question in modern astronomy. Is this object what it appears to be? Good morning. What you're about to hear represents a fundamental challenge to our understanding of cometary physics. On November 5, 2025, two independent observatories released post-perihelion images of 3I Atlas. The Naves Observatory in Spain and the Virtual Telescope project in Italy both captured the same thing. A compact, fuzzy ball of light. No massive debris cloud. No spectacular cometary tail streaming away from the sun. Just a small bright object that looks remarkably similar to how it appeared back in July, before it passed the sun. Before we dive in, if you want to follow this developing story, please hit subscribe and turn on notifications. Tomorrow there could be major data releases from NASA, and December 19th will be the most important observation opportunity in modern astronomical history. Your subscription helps us continue this coverage. Now let's get into what makes this so extraordinary. Here's what we know for certain. NASA's Jet Propulsion Laboratory confirmed on October 29th that 3I Atlas exhibits non-gravitational acceleration. The measurements are robust, standing at 3.7 standard deviations. In scientific terms, that's not noise. That's a real measurable effect. The latest data from November 4th shows the comet brightened by a factor of 5 in the green wavelength band between October 31st and November 4th. A 500% increase in brightness in just 5 days. And the acceleration is still there, measured at 1.38 astronomical units from the sun, about 206 million kilometers. Now for a natural comet, non-gravitational acceleration happens when gas escaping from the nucleus creates thrust, like a rocket exhaust. It's outgassing. Ice turns directly to gas, material shoots away from the surface, and Newton's third law pushes the comet in the opposite direction. The problem is the math. Avi Loeb, the Harvard astrophysicist who's been tracking this object since discovery, calculated that to produce the observed acceleration, 3I Atlas would need to lose at least 13 to 15% of its total mass. Not a small amount. We're talking about 5 billion tons of gas and dust. When a comet loses that much mass, you get consequences. Massive, visible, impossible to miss consequences. The escaping gas carries dust particles with it. Solar radiation pressure and the solar wind push this material away from the sun, creating the classic cometary tail that can extend for hundreds of thousands, even millions of kilometers. Comet Lemmon, a regular solar system comet, was photographed by the same observatory that observed 3I Atlas, just 2 days apart. Lemmon has a clear, bright cometary tail streaming away from the sun, exactly as expected. The comparison image is stunning, one comet behaving normally. One comet that, according to the laws of physics, as we understand them, should be displaying an even more dramatic tail because it just lost 13% of its mass. But 3I Atlas? It looks like a fuzzy ball. Compact. No extended tail structure. The coma, the cloud of gas and dust immediately around the nucleus, appears almost identical to how it looked in the Hubble Space Telescope images from July 21st. Before perihelion, Loeb put it simply, for a typical comet, this should have resulted in a massive coma with dust and gas that would have been pushed by the solar radiation pressure and the solar wind to the shape of a typical cometary tail pointing away from the sun. No such tail is visible in the new images from November 5, 2025. This is now officially the 10th anomaly, not speculation, not possibility. The 10th verified, documented characteristic of 3I Atlas that doesn't match what we expect from a natural comet. Here's where this story takes an important turn. On November 5th, Representative Anna Paulina Luna from Florida had a conversation with NASA officials. Remember, she had formally requested on October 31st that NASA release all imagery and data on 3I Atlas immediately specifically mentioning she was working with a scientist from Harvard. After that meeting, Luna posted on social media, "Just had a good conversation with NASA regarding 3I Atlas. As soon as the government reopens, they'll be releasing images and data. Unfortunately, due to bureaucratic reasons, they cannot until then." And then came the critical statement. Dr. Avi Loeb was correct in his early analysis of the abnormal tail. NASA has also noted this. Let that sink in. NASA, through their discussions with Congress, has confirmed that the tail is abnormal. Not that it's faint. Not that observing conditions were poor. Abnormal. This matters because NASA's official public position, stated by Acting Administrator Sean Duffy, has been straightforward. NASA's observations show that this is the third interstellar comet to pass through our solar system. No aliens. No threat to life here on Earth. Tom Statler, NASA's lead scientist for solar system small bodies, said, "It looks like a comet. It does comet things. It very, very strongly resembles, in just about every way, the comets that we know." Yet in private discussions with congressional representatives, NASA is acknowledging something is abnormal about the tail structure. The question isn't whether there's an anomaly. NASA has confirmed it. The question is, what's causing it? Let me list all 10 for you, because when you hear them together, the cumulative improbability becomes staggering. Anomaly. 1. Its retrograde trajectory aligns within 5 degrees of the ecliptic plane where all planets orbit. Random probability, 0.2%, anomaly. 2. It displayed a sunward jet, an anti-tail pointing toward the sun during July and August. This is not an optical illusion from geometric perspective. It's real, and it's rare. Anomaly 3. Its nucleus is 1,000,000 times more massive than Oumuamua and 1,000 times more massive than 2I Borisov, while moving faster than both. Combined probability, less than 0.1%. Anomaly 4. Its arrival timing brought it close to Mars, Venus, and Jupiter, while remaining perfectly hidden from Earth at perihelion. Combined probability, 0.05%. That's 5 in 100,000. Anomaly. 5. The gas plume contains much more nickel than iron, similar to industrial nickel alloys. The nickel to cyanide ratio is orders of magnitude higher than any known comet. Probability, less than 1%. Anomaly. 6. Its gas plume contains only 4% water by mass, while most comets are primarily water ice. Typical comets are 50 to 80% water. Anomaly. 7. It passed perihelion just 8 days after solar conjunction on October 21st. Perfect timing for any maneuver to be unobserved from Earth during the critical perihelion passage. Anomaly. 8. It arrived from a direction within 9 degrees of the famous 1977 WOW signal. Random probability, 0.6%. Anomaly. 9. Near perihelion it brightened faster than any known comet and turned bluer than the sun itself. Natural comets get redder near the sun due to dust. 3I Atlas got bluer, suggesting extreme temperatures or an alternative light source. Anomaly. 10. It exhibits non-gravitational acceleration requiring the loss of 13 to 15% of its mass, but post-perihelion observations show no evidence of the expected massive debris cloud. 10 anomalies, each individually unusual. Together, they create a statistical profile never before seen in any astronomical object, natural or otherwise. If you're finding this as fascinating as I am, please take a second to like this video. It genuinely helps the algorithm show this content to more people interested in these developments. Scientific integrity demands we present the opposing view. Professor Daryl Seligman and other mainstream astronomers make valid points. We've only observed 3 interstellar objects total. Oumuamua was strange. 2I Borisov was normal, behaving exactly like a typical comet. 3I Atlas is strange in different ways. With a sample size of 3, we don't know what's normal for interstellar visitors. These objects have spent billions of years in interstellar space, exposed to cosmic radiation, extreme cold, and environments we can't replicate in laboratories. Their chemistry, structure, and behavior might naturally differ from solar system comets in ways we haven't anticipated. The missing tail could have explanations. Maybe the dust particles are unusually small, scattering light in ways that make the tail invisible from certain angles. Maybe the composition is so unique that the outgassing doesn't produce the expected dust-to-gas ratio. Maybe we're seeing a cometary behavior that's common in other star systems, but rare here. These are legitimate scientific possibilities. The burden of proof for an extraordinary claim is high, and extraordinary evidence is required. Most astronomers lean toward the natural explanation because most astronomical phenomena have natural explanations. That's not closed-mindedness, that's scientific methodology. But here's why the next 42 days matter so much. On December 19, 2025, 3I Atlas will make its closest approach to Earth at 168 million miles. That's 1.8 astronomical units. Close enough for detailed observation, far enough to be completely safe. Between now and then, we have an unprecedented observation campaign. Let me walk you through the timeline. November 11, 2025, just 4 days from now, amateur astronomers with 8-inch telescopes will start seeing 3I Atlas in the pre-dawn sky. The comet will be in Virgo, near the bright star Spica, at magnitude 10 to 11. Thousands of amateur observers will be looking for one thing: is there a debris cloud? Has the comet visibly changed since perihelion? If massive outgassing occurred during the perihelion passage, we should see evidence immediately. An expanded coma, a developing tail. Something. If we don't, that strengthens the 10th anomaly significantly. The object would have brightened dramatically, accelerated noticeably, but shown no visible sign of mass loss. That would be unprecedented. November 15th and 16th, the comet passes within half a degree of the galaxy NGC 4691. Astrophotographers will have a unique opportunity. The juxtaposition of an interstellar visitor against a distant galaxy provides scale reference for measuring any coma expansion or tail development. November 17th. The Virtual Telescope Project is hosting a live observation event. They'll stream real-time images of 3I Atlas, allowing the public to see exactly what professional and amateur telescopes are capturing. This is citizen science at its best: real-time discovery, transparent observation, global participation. November 27th marks the beginning of something unusual. The International Asteroid Warning Network is launching a special observation campaign that will run through January 27, 2026. Now, IAWN doesn't normally organize campaigns for comets. They focus on potentially hazardous asteroids, objects that might impact Earth. But they're treating 3I Atlas as a training opportunity to improve comet tracking methodologies. Or perhaps, and this is speculation, there's heightened attention for other reasons. When the Pentagon's All-Domain Anomaly Resolution Office, the UAP Investigation Office, is confirmed to be monitoring an interstellar comet, it suggests the level of interest goes beyond routine scientific curiosity. December 2025. The James Webb Space Telescope makes its second round of observations. These will be detailed spectroscopic analyses of the comet's composition. Webb can detect molecules that ground-based telescopes can't. If there's anything unusual about the chemical emissions, anything that doesn't fit cometary models, Webb will find it. December 19, 2025, the critical date, closest approach. The Hubble Space Telescope will perform ultraviolet spectroscopy to determine gas composition and the sulfur-to-oxygen ratio. Ground-based observatories around the world will track the comet continuously. This is our best chance, possibly our only chance, to gather definitive data. By this point, the debris cloud question will be answered. Either it's there, confirming the natural explanation with some unusual characteristics, or it's not there, which would require us to rethink fundamental assumptions about cometary physics. February 2026. ESA's JUICE spacecraft data will be released. JUICE observed 3I Atlas on November 4th from about 40 million miles away, Using multiple instruments including cameras, spectrometers, and particle sensors, that data could confirm or refute several of the anomalies, particularly the composition measurements. March 16, 2026. Close approach to Jupiter. NASA's Juno spacecraft will observe the comet and can potentially use its radio antenna to search for electromagnetic emissions. If 3I Atlas is transmitting any signals, intentionally or not, Juno would be positioned to detect them. What makes this story compelling isn't the speculation about what 3I Atlas might be. It's watching the scientific method work in real time. We have anomalies. Documented, measured, verified anomalies. NASA acknowledges them, at least in private discussions with Congress. The question isn't whether these anomalies exist. They do. The question is interpretation. What do they mean? Do they represent natural processes we haven't encountered before? Are they the result of billions of years of interstellar exposure creating chemistry we don't understand? Or do they suggest something else? Loeb raised an important point in his latest analysis. He's not claiming 3I Atlas is artificial. He's asking what the responsible scientific approach is when faced with 10 anomalies. Do we assume it's natural and risk missing something extraordinary? Or do we keep all possibilities open until the evidence conclusively points in one direction? The majority of scientists lean toward the natural explanation. They may be right. In fact, they're probably right. But the minority asking uncomfortable questions aren't conspiracy theorists. They're following the data. They're saying, look at the accumulation of improbabilities. Look at the missing debris cloud. Look at the perfect timing. Look at the unusual composition. At what point do we take seriously the possibility that this isn't a typical natural object? Science advances when we ask difficult questions. When Galileo suggested the Earth orbits the Sun, he was challenging accepted wisdom. When Einstein proposed relativity, he was contradicting Newton. Progress requires someone willing to say, what if we're wrong about this? Here's another layer to this story that deserves attention. The government's response has been unusual. Representative Luna's involvement shows congressional interest at a level we don't typically see for comets. Her statement that she's working with a Harvard scientist, almost certainly Loeb, indicates serious scientific backing. The Pentagon's Aero office monitoring 3I Atlas is significant. Aero was created by Congress specifically to investigate unidentified anomalous phenomena. Their mandate covers airborne, transmedium, and submerged objects that cannot be immediately identified. An interstellar comet with unexplained characteristics fits that mandate perfectly. When Defense Scoop asked the Pentagon directly whether 3I Atlas is considered a national security threat, whether the Defense Department is assisting NASA's observations, no official answer was provided. The silence is interesting. Not alarming necessarily, but interesting. The government shutdown has delayed public data releases, but multiple sources confirm that observation and analysis continue behind the scenes. NASA intends to release relevant findings once the government reopens. That data will include high-resolution images from the Mars Reconnaissance Orbiter's HiRISE camera, taken on October 2nd when the comet was just 28 million kilometers from Mars. Those images could be crucial. They offer a side view of 3I Atlas's coma at high resolution, 30 kilometers per pixel. If there was significant outgassing, if a debris cloud was forming, HiRISE would have seen it. The fact that these images haven't been released yet, combined with Luna's statement that NASA confirmed the abnormal tail, suggests they may show something unexpected. Whether 3I Atlas is the strangest natural comet ever observed, or something that challenges our assumptions about what's possible, we're privileged to witness this moment. An object from another star system is passing through our cosmic neighborhood, close enough to study, carrying information about conditions in a place we'll never visit. The odds of this happening during your lifetime were incredibly small. The odds of having the technology to study it properly were even smaller. The odds of having spacecraft at Mars, Venus, and en route to Jupiter, all positioned to observe it. The odds of having the Hubble Space Telescope, the James Webb Space Telescope, and ground-based observatories coordinated enough to track a single object for months? Nearly zero a century ago. Yet here we are. This is what humanity can do when we work together, when curiosity overrides fear, when the question, what is it, matters more than what do we want it to be. In 4 days, on November 11th, amateur astronomers will join this investigation. If you have access to an 8-inch telescope, you can observe 3I Atlas yourself. You can contribute data to the Minor Planet Center. You can be part of the community answering the debris cloud question. On December 19th, thousands of telescopes will point at this object simultaneously. Professional observatories, university research telescopes, amateur astronomer setups in backyard observatories, all looking for the same answers, all contributing to our understanding. This is citizen science at its most powerful. The data professionals collect will be cross-referenced with amateur observations. The combined data set will be more comprehensive than any single observatory could produce alone. Your observations matter. Your data contributes to the answer. If you want to follow this story as it develops, subscribe to this channel and turn on notifications. We'll have coverage as soon as major announcements happen. The Virtual Telescope Live event on November 17th. The December 19th closest approach. The data releases from NASA. We'll be here with updates. To everyone watching, thank you for engaging with science when it's uncertain and complicated. Thank you for being the kind of person who hears about 10 anomalies and wants to understand them rather than jumping to conclusions or dismissing them out of hand. Keep watching the skies. Keep asking questions. Keep demanding transparency from the institutions we've entrusted with this knowledge. And keep that sense of wonder alive. Because whether 3I Atlas is the most unusual natural comet in recorded history, or something that rewrites our understanding of what's possible in the universe, we're watching it happen together, in real time, with better data than any generation before us. The missing tail is either the beginning of a new understanding of cometary physics, or it's evidence that we're dealing with something we've never encountered before. Either way, science wins. Either way, we learn something extraordinary. The next 42 days will tell us which.